Hello, hiya, Claire, and hiya, Kutetano as well. Welcome to this latest lecture in the A Star series. Today what we're going to do, we are going to focus on ratios. We are going to have a look at some of the general rules to do with ratios. Then we will have I look at a couple of questions from past papers as well. So yeah, just before I start, I'm just going to share, just in case either of you need it, the playlist for this series of lectures in the chat. So I'll share two series there. The first one I'm going to share is yeah, the full previous series. So if you want to jump ahead, sorry, the first one I mean is the new series. So this lecture is being recorded as always, so you can watch it back. It will be uploaded there later, and you can watch previous lectures in the series. Equally, the entire previous series is there as well if you want to jump ahead or watch a different perspective on the same stuff. And as always, I'm going to share my board on the screen as I go along. So if either of you've got any questions, please don't hesitate to ask. You can either put it in the messages, or you can just put your mic on as well. It's not a problem at all, and ask. So basically, to start with, we'll just do a little bit of an introduction. What are ratios? So ratios are a way of expressing things in relation to each other. So, for example, if x and y are in the ratio 1 to 3, it means for every 1 of x, that is 3 of y. So that's all it means to it. It's similar. I don't know if we'll touch on them today actually, but it's similar to sort of ingredients or recipe or anything like that. It means for every sort of one part of x, there is 3 of y. And normally you'd see ratios written out like this. You'd have the x next to the y with a 1, sorry, 2, 3. Okay, and so what it means in effect is, welcome as well here. So what it means in effect, you've got the 1 of x to 3 of y is, therefore, if that was 3 of x, which is in effect 3 times 1, that would be 9 of y. So 3 times 3. So ratios, in other words, what that means, ratios always stay in proportion. You can keep them in proportion by multiplying or dividing all the parts by the same amount. Okay, so hopefully that makes sense as a starting point now for what a ratio is. And obviously we've studied recently, we've studied fractions, and it's good to understand the relationship between ratios and fractions. So ratios can be written as fractions. And so, for example, using the example we've got here for ratio x to y 1 to 3. We can say there is 1/3 as many x as y. So you could just write it in that way. That's 1/3 as many x as y, but now in the ratio 1 to 3. Or we can say, we could write the other way around, that are 3 to 1 as many y as x. So you could write it around the other way round, putting y on the top. So for every 3, all of these mean exactly the same thing. Or so as there are 4 parts, so 4 parts to the ratio, which is from the 1x plus 3y. In total, we can say 1/4 of the total is x and 3/4 are y. So these are all ways you could write it as a fraction. You can write it as x to y, y to x, or you could write x all y to total. And if you do it to total, the denominator is always going to be total amount of parts. So I just give a second to copy that and then we'll move on. Okay, so what we're going to look at next, we are going to look at basically we are going to have a quick look at ratios, simplifying ratios. So just like with fractions, again it relates to fractions. Sorry about this. So just like with fractions, you can simplify a ratio by dividing every part by the same amount. When this is no longer possible, the ratio is in its simplest form. Okay, so let's say, for example, sorry, does one of you have a question? Go for it.
Yes, please. Sir, can you please go back on the last slide?
Yeah, okay, no problem at all. So I'm just going to, in fact, yeah, I'll do it right now, no problem. Can you just let me know when you've done it, and then I'll carry on forward.
Okay, thanks.
Yeah, no problem. Exactly. Remember, if you're a bit behind on it or anything, you can always take sort of a screenshot and then copy it down later. But yeah, just tell me as soon as you're ready. Okay, so I'll just catching up. Brilliant, excellent. No problem at all. All right, so sorry, I've skipped ahead on slides here, but here we go. This is where we were before. So, giving an example of this for simplifying, so you could have, e.g., write the ratio. So let's say we've got 30 to 90 to 150 in its simplest form. And so the way you would do this is no different than how we dealt with fractions. Even though here there's 3 parts, so now we just got to find common factors of all 3 parts. Well, all 3 of these, they end in 0, and anything which ends in 0, remember, you can divide by 10. So we can do that, and that's just going to give us 3 to 9 to 15. Remember, to divide by 0, you just take, divide by 10, you just take a 0 off. And then we got 3 to 9 to 15. So obviously we're dealing with odd numbers, so they can't divide by 2. But all of these numbers are in the 3 times table, so we could divide again by 3. And that's going to leave us with 1, 2, 3, 2, 5. And again, just like simplifying a fraction, you could do this all in one move. You could have divided the first ratio by 30 and you would have ended up in the same place, but you don't have to do it all in one go. Just whatever works for you. As long as you end up at the simplest form, then that is fine. Okay, and so just as you can simplify ratios, what you often have to do as well with ratios is scaling ratios. So, as mentioned earlier on, just as you can simplify a ratio by dividing, you can scale by multiplying all parts by the same amount. And often if you get a scaling, it's going to be in the form of a question, and in scalings what you have to do. So yeah, let's give an example of this here. So we got a question: meringue is made by mixing cups of egg whites and sugar in the ratio. So I'll just help with the presentation here. 3 to 7. We asked how many cups of sugar are needed if 12 cups of egg white is used in the mixture. So here we've got a ratio, and how I would answer a question like this is just setting up the ratio first of all. So we've got egg whites, we can put a W to S to sugar. We've got our original ratio, which is 3 to 7. But we know that egg whites is going to be 12 cups used. So we know we've gone from 3 to 12. So to find the scale factor, simply divide the amount of egg whites needed by the amount of parts in the ratio. So that's, in other words, 12 divided by 3 equals 4. And logically, if 12 divided by 3 equals 4, that means you can flip it around the other way. So we can do 3 times 4 equals 12. And then remember, we're scaling, just as when you're simplifying. Whatever one part of a ratio is multiplied by, all parts are multiplied by. So here we've got the 3 to 12 times 4. We are going to do the same with the 7. So we can do 7 times 4, and that's going to give us our final answer of 28. That's a lot of cups of sugar, but yeah, that's the answer. So you see, with scaling, it's unlikely you'll get a question where it just say scale a ratio by 4, it will probably be a question like this where you need to solve, where you need to find a number with it, and this will get you to your conclusion at the end. But again, I'm just going to give a second to copy this down, and then we will move on. Okay, so moving on from that, and again, if anyone does get behind at any point, if you need me to go back, please don't hesitate to ask. But the next thing we are going to look at here is we're going to look at dividing amounts into a ratio. And this is a really key skill with ratios. Dividing amounts into a ratio. So I'll just put this key skill. And so to do this, we need to divide the total of the ratio by the amount of parts to find the value of one part. Then we can scale each part of the ratio by the value of one part. So it's a bit like scaling in that way, but we've got to find the value of one part, and the value of one part is effectively going to be the scale factor, how much is done. So we'll give an example of a question here. Okay, so we've got Aaron, Kim and Paul split £6,000 in the ratio of 3-4-5, and we need to work out how much money did Aaron receive. Okay, so first of all, we want to find out total parts. So find total parts. To do that, we can do 3 plus 4 plus 5 equals 12. And so once we've done that, we can divide total amount by total parts. So now we can do is where the total amount is 6,000 divided by 12 equals, and how you can do this, the easiest way, if you've got 6,000 divided by 12, okay, you could write out bus stop if you really wanted to, but you don't need to. What you can do is just do 60 divided by 12, which is 5, and then add the 2 zeros. So what we know from this is that one part, really what we're doing is 1/12 equals £500. And then now we've done this, we can multiply Aaron's parts by the scale factor. So all we've got to do that, well, our scale factor, how much go is £500. We can just do 500 times 3. Again, all you've got to do here is 3 times 5 gives you 15. Add the 2 zeros. And so it gives us £1,500. And just it's worth pointing out, although it doesn't it maybe looks a little bit different. This is exactly the same skill we've already practiced in fractions, even if it looks different. So basically, this is the same as fractions of an amount. Because if you think about it, Aaron has 3/12 of the total. That's 3/12 of the total. So it's like we found out what the denominator would be if it was a fraction, which is 12, by adding up the total parts. Then we have divided, the total by the total amount of parts, and to give us 1/12, and then we've multiplied by the amounts, and effectively we've done 3/12 times 6,000, or we've done 3/12 of 6,000. It's exactly the same skill, even if it's written out slightly differently. Okay, now I'm just going to show a question here. This is actually the same skill, but it's a past exam question. And it's the same skill, but it's got an extra stage to it. And often I find with ratios in the exam, you'll get the skills we'll see today, but you might get additional stages to them as well. You might be, but you have to use some lateral thinking like you do on this to put the question together, even if the underlying skill is the same. So we've got a shop sells packs of black pens, packs of red pens, and packs of green pens. We are told there are 2 pens in each pack of black pens, 5 pens in each pack of red pens, 6 in each pack of green pens. And we're told on Monday the number of packs of black pens sold to the number of packs of red pens sold. Number of packs of green pens is 734. Then we're told a total of 212 pens were sold. Work out the number of green pens sold. Well, it's still, we're doing the skill we've just done. We need to find out, we need to split it into a ratio and then multiply by the amount of green pens sold. But we need to make a ratio of a pen sold, because we've got how many pens there are in each pack, and we've got how many parts have the ratio of packs. So to get pens in ratio, we need to do pens in pack times the amount of packs in ratio. So in effect, we've got to make ourselves a ratio here to get to pens, because our ratios of packs is not of pens. And so we can do that down here if we do black to red to green. Well, then we can do, we know we've got the ratio, which is 7, 3, 4. But we've got the pens per pack, so we need to multiply by 2, 5, and 6. So in this case, it's not a scale factor, it's every type of pack has a different amount of pens. So black pens sold would be the 7 packs times 2 pens, giving us 14. Red would be the 3 packs times 5 pens, so 15. And the green, the 4 packs times 6 pens, which is 24. So this gives us our new ratio of 14 to 15 to 24. And so that means total parts, because remember now, even though we've got some nasty numbers, we're on familiar field from here, equals 14 plus 15 plus 24, which is going to give us 53. And that means now we can do 1 part equals what a total pens sold, 212 divided by 53. Now this is actually from a non-calculator exam, and I know it looks horrific because you might think that's not fair, how would they expect us to know the 53 times table. But if you ever get a question like this in a non-calc, just think it's got to go in nicely. There's no way that it's not going to go in nicely along the way. Sorry, I just seen your note. Tana, which part are you having difficulty reading? The Aaron, Kim and Paul split. Let me come back to that. Right, exactly which part it is, and I'll come back to it. Come back to it in a second when I finish this. But we've got 1 part equals 212 divided by 53. So as said, it's got to go nicely if you're in a non-calculator paper. They wouldn't be that horrible. And we know just as 5 times 4 is 20, 50 times 4 equals 200, 3 times 4 equals 12, which means 53 goes into 12 4 times. Goes in 4 times. So we know now 1 part equals 4. And so we can say then green pens equals 24, just the amount of pens in a ratio, times by 4, which equals 96. Sold. And that's the final answer there. Oh, right. Just give a second to copy, and then I'll see if I can make it any bigger, just in case you're struggling to read a question. Okay, so I think it might have been this question here you're struggling to read, Kutatana, but correct me if I'm wrong. It says, example, Aaron, Kim and Paul split £6,000 in the ratio of 3 to 4 to 5. How much money does Aaron receive? So hopefully that's cleared it up, but let me know if there's still a problem. Okay, we're going to move on from that for now, and we are going to move on to our next skill here. And this is differences between parts of a ratio. Between parts of a ratio. So sometimes instead, oh sorry, I don't know what's happened now, 1 sec. Sometimes instead of being given the total of something, you'll be given the difference between the total of 2 people in a ratio. And so on a question like this, you need to find, you basically still need to find the value of 1 part. And in fact, I'm going to do this all the way across the top because I'm going to put the question across here as well. You still need to find the value of 1 part. And so to do this, you divide total between the people by the amount of parts between them. I'm going to give an example of a question now to show you what I mean. Okay. So we've got here, we've got Josh, James and John share sweets in a ratio of 1 to 4. Josh has 9 sweets less than John. How many sweets does James have? This question always annoys me because for drawing out a ratio, it's a bit annoying, but it's giving them all the same letter to start with, but not to worry. Just means we've got to write out the whole name. So we've got a ratio here, which is Josh, James, and John. But we've been given information about Josh and John. So really we can just write out, if we want to, the ratio from Josh to John. And for now, we can just ignore James. So Josh has 1 part and John has 4 parts. And we know between Josh and John, there are 9 sweets. We've been told that. So we can mark up here 9 sweets. And between them as well, we know there's 3 parts. Just to explain what we've done now, we've got parts between John and Josh equals 4 minus 1 equals 3. So we know that the 9 sweets represents 3 parts. And so, therefore, to find the value of 1 part, we can divide the sweets between them, which is 9, by the parts between them, so 3. And so you can say down here, exactly 1 part equals 9 divided by 3 equals 3. And so therefore, as James has 2 parts and 1 part, equals 3, his total sweets equals, I'm just going to write it out below, 2 times 3, and so equals 6 sweets. So you see sort of how you solve the question is not actually different. You've got to find the value of 1 part, and then once you've got the value of 1 part, you can use that to find the overall answer. It's just the way you find 1 part is a little bit different. All right. So just going to show you a couple more things that come up with ratios. So next thing we're going to talk about is here we are going to talk about reducing a ratio to 1 to n. And so you may get a question where it asks you to give a ratio in the above form. And so all this means is that the left hand side of your ratio must be 1 and the right hand side is in proportion. On a question like this, n, so the number on the right, can be a decimal slash fraction, either way depending on how you write it, as long as it's in proportion. So normally with a ratio you don't get parts where well, one part is a decimal, but you can do here, so, or a fraction, so you could say, for example, e.g., write the ratio 12 to 30 in the form 1 to n. And so we can write out our ratio below. We've got 12 to 30. Now we know, but the left-hand side is going to become 1. So in order to get something to 1, to divide by, to get to 1, you always are just going to divide something by itself. Because it's like splitting 12 into 12 equal parts equals 1. Whatever it is, it could be 24.625. You divide it by 24.625 to get to 1. It doesn't matter what it is, you divide a number by itself to get to 1. And now whatever we do to the left hand side, we have to do exactly the same to the right hand side. So we need to divide by 12, and 30 divided by 12, or 2 12s are 24, 24 remainder 6, that is 2.5. So our final answer would just be 1 to 2.5. So that's all it means when it asks you to write a ratio in the form 1 to n. All right, so just going to look at a couple more things here. So you might get a question as well. You might get one like this question. I'm going to copy over. It's a little bit different where you may be given a question where you are given information and you need to turn it into a ratio. So just give like the example below. So we've got Asmil, Ryan and Kim each played a game. Asmil's score was 4 times Ryan's score. Kim's score was half of Asmil's score. Write down the ratio of Asmil to Ryan to Kim. So the first thing I'd do on a question like this, I'd just write out my letters, making sure I've got everything in the correct order because it's A to R to K. Well, now let's look at our information. So we've got Asmil was 4 times Ryan and Kim's score was half of Asmil. So we know Ryan's score was the least. So whoever is the least, I would always mark as 1. And then we can work from that to get our other answers because we know Asmil scored 4 times Ryan. So we can just do 4 times 1 to give us 4. Kim scored half of Asmil, so we can just do 4 divided by 2 to get half, which gives us 2. So final answer, as simple as that, is 4 to 1 to 2. And just to note at the bottom, note in the final ratio, all parts must be integers, so whole numbers. So therefore, if you calculate that one part of the ratio is a half, you need to multiply all parts of the ratio by 2. So say, for example, if it said Asmil had 3 times as many as Ryan and Kim had half of Asmil. So you'd end up with 3 to 1 to 1.5 because 1.5 is 3 divided by 2. And so all you would do in that case is multiply all parts of the ratio by 2 so that Kim becomes a full number and you'd end up with 6 to 2 to 3. So it's just something to be aware of. It could happen in the exam like that and give you an extra step to this question. All right. So just going to show one more type of thing with ratios here. And again, this is a skill that will come late in the exam if it comes at all. So in this, we're going to call it combining ratios. So you may get a question where you are given two ratios and you need to combine them to make one ratio. The trick to this is to find the common multiple of the part of the item in both ratios. So show you what I mean with an example in a sec. I'm going to do this all on one page actually as well because it's quite a big example. And so we're given a question here. Again, this is from a past paper. And so we got in a village, the number of houses and number of flats are in the ratio 7:4. The number of flats and the number of bungalows are in the ratio 8:5. Out of 50 bungalows in the village, how many houses are there in the village? All right, and so what you're going to do here to solve this is you want to write out a ratio of all three things. And how I would always present it, we've got house and flats to bungalow. So we can write H to F to B and put the two ratios we're given on top of each other because we've got houses to flats is 7:4. And then we got flats to bungalows is 8:5. So as flats are in both ratios, in order to combine our ratios, we need to find a common multiple of the flats in ratio A and the flats in ratio B. Just like when finding common denominators, if one goes into the other, we only need to change one ratio. If there is no obvious multiple, we need to multiply our numbers. So it's just basically, it's a little bit hard to explain for you, but it's just like when you are dealing with fractions and you want to find a common denominator when you're adding or subtracting. So in this case, we've got 4 flats in the first ratio, we've got 8 flats in the second. So to find a common denominator is 8 because 2 4s are 8. So all we got to do here is multiply our first ratio by 2. And so that means we're going to have 8 here for flats. Bungalow stays at 5. Houses, we've got to do 7 times 2, which gives us 14. And if you think about the maths, when I say it's a bit like adding fractions, it's like if you had 7/4 plus 5/8, you would nearly have to multiply this ratio by 2 and it would become 14/8 plus 5/8. So it's the same logic as when you're dealing with fractions. And if it didn't go into the other one, you would have to multiply them together and change both ratios, just as you do the crossover method with fractions. But now with this question, that's all we need to do at that stage. And so now we've got a ratio down here. And we know, we have been told there are 50 bungalows. So we know here, so again, we can find out one part, or our scale factor. In fact, we're going to call it a scale factor, but it's basically the value of one part. Either thing, I used to as a bit interchangeably, they mean the same thing. So scale factor though equals 50, the amount of bungalows, divided by 5, the amount of parts equals 10. which means we want to find out the amount of houses, and we've got 14 parts times 10 equals 140. So houses equal the 14 parts times 10 equal 140. So you can see this last part is just a scaling question. Okay, so again, hopefully that's made sense. And yeah, we will move on in a second. Welcome, Tiffany, as well. All right, so just give a second to copy this down. Exactly, and then we'll move on and just look at a couple more things. Okay, so we're just going to look at a couple of general examples to finish from different skills. So we have got question. Steve receives £200 each month from his parents as an allowance. 20% of his money is spent on his football magazine subscription, and the rest he spends on football stickers, sweets, and fizzy drinks in the ratio 5-1. How much does Steve spend on football stickers? So as you can see here, you might get a question which involves ratios, but it might combine other skills as well, which is the case here. So the first thing it says, the order says 20% of this amount, so this represented 200, is spent on a magazine. So we need to get rid of that before we work out the other part of the ratio. So we got magazine spending equals 20% times 200. Well, hopefully you remember from our percentages class. You can work this out in a couple of ways. You can either divide by 5 or divide by 2 times 10. So we're going to do that. So 10% equals 20, because you just remove a 0 to get 10%. 10% is divide by 10. And then times 2 equals 40. And so the money he had minus the magazine subscription equals £160. All right, and now we've done that. Now we're actually on the ratio part. So we're going to put an A here. Now we've dealt with that. We've got B. We've got the rest. He spends on football stickers, sweets, and fizzy drinks in a ratio of 5-2-1. If we do that down here, B, or we can put FS to SW to FD in a ratio 5-2-1. And so what we need to work out equals total parts equals 5 plus 2 plus 1 equals 8. And then we need to do that for one part equals 160 divided by 8. Well, the easiest way to do that is 16 divided by 8 equals 2 plus the 0, so equals £20. Remember, the £20, what we've effectively worked out there is 1/8, because splitting something into a ratio, finding a fraction of an amount, there's no material difference to it. You're doing the same thing. And so finally, we want to find out how much does he spend on football stickers. Well, football stickers, if we look at our ratio, is 5 parts. So we can say football stickers equals 5, the amount of parts times the scale factor, or the value of one part, 20, and say equals £100. That's a lot of money on football stickers. But yeah, there you go. And so that's the final answer there. So a question like that, really, the key behind it is just making sure you split it into the separate parts of the question, dealing with one stage at a time, not trying to jump too far ahead or anything like that. Okay. And then we'll just do one more question here for today. It's a two-part question, but we're going to go for it. So we've got here we have got Alik, John, and Kate track the number of books they read last year. John read twice as many books as Kate, but Alik read 4 times as many as John. You need to write down a ratio of the number of books read by Alik to the number of books read by John to the number of books read by Kate. So part A of this question is very similar to a question we've already done, I think, even in terms of numbers and everything as well. Again, we just need to write out our ratio. We've got A 2J, 2K, and we want to work out who's going to have the least. It's Kate, but Elite with 4 times as many as John. So we know that Kate read the least. John read twice as many, so John is 2. And Elite read 4 times as many, so we can do 2 times 4, which gives us 8. So we got the ratio here, 8 of 2 to 1. And then underneath, we're told Alik read 63 books more than Kate last year, and we need to work out how many books they read in total. So we could just draw out our ratio. It's like one we had earlier. We're only worried about AK right now. So we know AK, and we know between them is 63 books. And in the ratio, they're 1 to 8. So we also know between them there's 7 parts, because one basically is the gap between the two. The Alik has 8 minus the amount of parts for Kate, so there's 7 parts. So 63 books equals 7 parts. And therefore, 1 part equals 63 divided by 7 equals 9 books. So therefore, the value of 1 part, or the scale factor, whatever you want to call it, is 9 books. And we've been asked in this question to work out how many books Alik, John, and Kate read in total last year. You could actually interpret this 2 ways, to be honest. I don't think it's the best written question. You can mean how many books do they all read individually, or you mean how many books they read all together. So we're going to do both here. We're going to do, well, we've got A, J, K. We've got 8, 2, 1. We've got a scale factor of times 9. So 9 8s are 72. We've got 2 9s are 18. We've got 1 9 equals 9. So that's how many books they read each in total. But total books read, you could either add these all, or you could do total amount of parts, which is 11, times the value of 1 part, which is 9, which gives you 99 books. So as I say, it's not immediately clear to me what they're expecting you to do here. The way the wording is probably more the second thing, but you could interpret it as the first thing. I think in a question like this in an exam where the writing's a bit open, they will probably accept both answers. They tend to do that on a question like that, where they accept that the wording could be reasonably interpreted in more than one way. All right, well, that brings us to the end of the examples I'm going to go through today. So I'm going to leave it there for today, unless any of you have got any questions, in which case feel free to put your mic on. But yeah, if not, we will finish for the day. So thanks a lot to all of you for making it along. We have got, of course, we've got a lecture tomorrow as well. Off the top of my head, I believe it is probability. Yeah, it is indeed. So we've got probability tomorrow at 7:15. So yeah, thanks a lot to all of you. Have a great night and hopefully see you then. Okay, bye bye.